Testing, testing, one, two, three. Hi, and welcome to today's webinar. My name is Edwin Robledo, and today it's going about talking about how to manufacture your circuit boards, how to get them manufactured, how to create the appropriate files to actually get your circuit boards manufactured. You'll be getting in the mail something that looks something like this in the mail. That way you could either use your reflow oven or actually manually solder them to the board, okay? So this is what we're going to be talking about today. How do I get this made, okay? This is what it's all about today. So we have some special shapes here as well. As you can see, these are been made through Osh Park, I think, and these as well, and we have many more. So how once you design your board, what's the post process to actually have your boards actually made by the manufacturer, or maybe a prototype house? Now let's go ahead and share my screen. Okay. Now, I have a session of Fusion 360 already open, and I'm going to use one of our example boards just in case you wanted to reproduce this on your own. You could do, and I'm going to use one of the example boards that comes with Eagle, okay? Even though I'm going to be using Fusion 360 for the entire process. So here we go. I'm being said that my volume is very low, so let me see if I could fix this. Let me know if that's any better. Testing, 1, 2, 3. Hopefully that's much better. Okay. Okay. Is this any better? Okay, very well. Okay, thank you very much. Appreciate the comments there. And Jorge Garcia is our product support specialist for Eagle and Fusion 360, and he'll be manning the chat and helping us out, answering the questions on the chat. I'll do my best to participate there as well, but while I do the live chat. So now at the end, if you want, go ahead and join us on the forum. And on the forum, you could post any questions based on this video, and we'll address your questions there as well, okay? Now, I have a Fusion 360 session open up, as you can see already on my screen. I'm sharing my screen right now. And I'm going to just use one of our examples that we have. Let me open this up. I already created the electronic document and loaded the schematic as well as the board file. Just give it a minute to load those up. This is going to be a kind of a quick tutorial today, so I'm going to say no for now. I don't really need the 3D PCB. So this is one of the example files that actually come with Eagle, but I loaded it in Fusion 360. The reason I wanted to do it this way is because I wanted you to be able to appreciate that the Eagle files are 100% compatible with Fusion 360. Okay, that's mainly why I'm using Fusion Eagle files. That way you can see how that works. Now we have the schematic. This is the electronic document. And one recommendation I always have is that if you see that the file has an asterisk on the tab name there, it just means that it needs to be saved. There might be some changes to the file, and it needs it needs to save to the latest version. So just go ahead, and I like to save it from the electronic document because then it cascades to all the other editors, the schematic and the board layout editor as well. So I just click on save here. That way my dirty file becomes a clean file here. So it saves everything and go. Yeah, of course, here's my schematic. I'm just going to get rid of the data panel. That way I could expand my editor, okay? Here's my schematic and here's my board. First thing you should always do before actually creating your manufacturing files is go ahead and take a look at your DRC. That way you can verify how many layers you're going to have and take a look at some of the other settings that you may want to consider before going to manufacturing. I always strongly recommend that you do this, okay? So let's go ahead and run DRC. And to get to the DRC screen, you're going to go to where it says Rules ERC tab right here. And then you're going to click on the DRC option icon right here. I'll be using arrows really short. So yes to go. So as you can see, I went from DRC right there, and this brought me to this screen right here. Now here, you do have the option of loading a DRU file if you're using a manufacturer that is familiar with Fusion 360 electronics or with Eagle. They actually provide you a DRU file which is compatible. That way you make sure that you're creating manufacturing files, that you're taking into consideration their constraints or their preferences. That way your circuit board complies with their system. That way manufacturing gets done a lot faster, okay? And that's where you would go there. And we'll take a look at that a little later in my next example. First thing I want to take a look at is the layers. That's the first thing I want to always take a look. As you can see, this is a 2-layer board only. So I have a top layer, which is layer 1 and layer 16. Please remember that you're always going to work from the outer layers to the inner layers. It's always going to work. Therefore, I only have one via size, one via depth. And our vias, which are our points of transition, are going from the top layer all the way to the bottom layer. On a 2-layer board, that's really the only options that you have, okay? So we have our top and our bottom layer as well. We have a 2-layer setup. Also, you want to also take a look at your clearances, which we've already done this earlier already, and the DRC. Our distances from the board outline to anything that has to do with copper. My drill hole size are going to be used on the board. And the sizes actually is where you define the thickness of your boards, okay? Now, once you've just browsed that, and you should have done this already when you started with the board. This is the first thing you should actually do before actually laying out your circuit board. I'm going to cancel this really quick because I want to go through the layer setup. How is it going to look when you generate your Gerber files? Okay, now let's go back to the Design tab because I want to take advantage of this layer right here. Now, when you're creating Gerber files, when you're creating manufacturer data files for a circuit board, you're not creating one file. You're creating multiple files. And each file is going to consist of a combination of layers, which create that one layer. So, for example, when I create my manufacturing files for the top side of this circuit board that you're looking at here, I'm only going to be using a layer, I'm going to be creating a file that consists of the top layer combined with pads and vias, because that's all of the copper for the component side of my board. So I click OK here. That way you could take a look at what it's going to look like. I'm going to go ahead and calculate this polygon that you see here, that it's kind of dotted. That way you actually see what it's going to look like, okay? I'll run rat's nest, and there's the pour. Now let's take a look at what my board actually is going to look like when I receive it in the mail. Let's go back to the manufacturing tab, and let's go ahead and click on right here, Cam Preview right here. It's called Cam Preview. Okay. Now the Cam Preview is going to let me know how does my board look like when I receive it in the mail. Unless you're paying for the service to get it populated, which can be kind of expensive. We actually usually use a reflow oven, or we just manually solder with a soldering station that we have. Now, this is more or less what you're going to get back in the mail. So you could actually take a good look at what you're getting. This is going to be the top side of the board, and this is going to be the bottom side of the board right here. It's going to switch in a minute. This is the bottom side of the board, okay? This is what you're going to be receiving. Now, the nice thing of this manufacturing preview is that you could get a lot more data from here. If we go to the boards tab, and I start expanding a lot of the information we have here, it lets us know how many signals we have, lets us know how many drills we have, plated through holes. Plated through holes are usually points of transition when you're transitioning a signal from one layer to another one. And non-plated through holes are just usually where you're going to screw in maybe a screw or something like that. It's going to hold onto the board, and it does not really need any copper. Okay. How many pads that we have. This is counting surface mounted pads as well as through hole pads as well. How many components and our layer stack up. These are statistics that are always really interesting to know, and maybe to even provide this to the board house by means of through the bill of material, or creating a text file that has this information. Now you're going to notice shortly that we actually do include some of this information already with the board when we create the manufacturing files. Okay. I just wanted to bring this up really quick. That way you can know about it. Okay. Now, if you want to get more information about the drills, here on the drill tab, you'll get how many drills you have, how many are plated through, how many are not plated through, and you get a count and the sizes that there are. Okay. So we have a 1.85 millimeters, 38 of this size, and 137 of this size. Apparently all the vias are of this size, and these are just maybe some mounting holes, as well as a connector I think there is here. Okay, these right here. Okay. Now there's two ways to create the Gerber files, okay, or the manufacturing files. So as I told you, this is going to be what my top copper layer looks like. I'm going to go back to the design. I'm going to do one more example before I actually go to the CAM processor, and I'm going to disable the top layer, and I'm going to enable the bottom layer. And this is what my bottom copper is going to look like, okay? So when I submit this to the board house, this is what my bottom is going to look like, right? Now let's go to the manufacturing tab. I'm going to go ahead and just enable my layers again. Remember, you have some layer presets right here. So I could go my presets for my bottom, my presets for my top, or just my preset standards, which is just going to enable almost all the layers. All the most useful used layers for a two-layer board. Okay, as you could see here. Now let's go ahead and go to the manufacturing tab. You're going to notice that I have three, these are the ones that you're going to be using the most right here, these three right here. Okay, and I'm going to use, now we can export IPC 356 format as well, and you could export the pick and place, but pick and place is actually going to be part of my manufacturing as well. When I do this, it's going to be added to what we do. So first of all, let's go to a one-click solution that we have here. As you see right here, this one says CAM export. Now before I do this, I want to go to DRC because I want you to take a look at something. You see my layer set up here? I have two layers only, right? So let's go back to manufacturing. I really want you to see what I'm going to do here. So when I go back to manufacturing, I'm going to go to CAM export. This is kind of like a one-click solution. What this is going to do is that it actually will generate all my Gerber files for me without having to do any type of processing. So if you have a straightforward two-layer board or four-layer board, You could use this if there's nothing that you need to modify on your output. If I haven't used any other layers or put any other special information on any other layer and like that, and use the top, the bottom for your copper, and there's no other layers that really need any consideration, you could use the one-click solution. As you could see right here on the bottom, it loaded one of our templates. You see this template right here? It says template 2-layer. That's, in essence, it picked up from our DRC. That's why I wanted you to take a look at DRC really quick, because you'll notice that it picked up the amount, it selected the template to coordinate of how many layers I had set up on my DRC. So as you can see here, my template is a 2 layers, therefore I only have a 2-layer, so it actually matches. Okay, so that's going to actually happen automatically. Okay, now all the files are going to be zipped up for me, so it's going to compress all the files. As you can see here, you'll notice here it's going to zip up all the files. When I actually process this, it's going to ask me where do I want to put the file. So I'm going to go ahead and click OK. The files are going to be going to a folder in my Documents folder. It's called Fusion 360. There's a subfolder already there that's called Electronics CAM. As you can see, the file that's going to be created is already zipped up. Okay, I'm going to go ahead and create a folder for it, and I'm going to call it Nordic. And click on Create, as you can see here, because I want my files to go to this subfolder right here. And I'll click on Save. Okay, all the files were created. It keeps on opening up the folder on my other screen. Sorry about that. I'll bring it over. All the files are zipped up, as you could see. And there's the path where it put it. It put it under my Electronics CAM, Nordic, and all the files are zipped up. Now you could actually email this to the board house or just upload it to whatever board house you wish to use. Fusion 360 Electronics CAM processor is using a very same format that Eagle uses. Therefore, almost everybody understands and accepts the the Fusion 360 format because it's been around for so long. Okay, and since we have adopted the same format, you should have no problems at all by submitting this to the board house. Now, let's go through one more example. But this sample, we're going to get a little bit more creative. There's going to be more steps that we're going to be using, okay? So we're going to actually be using this one, which is actually executing the CAM processor. But I want to explain this with a bit more of a dense board. That way you see what's different. So let me just go ahead and close this project. Let's go ahead and load this one right here, the BeagleBone. Okay. It will cascade and open up the board and the schematic, and most probably open up the 3D model as well. We don't really need the 3D model, but it's there. It will open it up automatically. As I stated earlier, the first step that you should always do is take a look at your ERC. That way you have an idea of how many layers this board is actually going to be consisting of. Okay, so let it load really quick. I should have maybe have these loaded before I had began the webinar. I didn't think about it. That way you don't have to wait. Okay. And close the data panel. Let's go over to the board. Okay. So remember, we were talking about the first step that you should always do is just take a look at the DRC. That way you could see what's your layer stack up looking like. That way you know what to expect when you output your manufacturing files, okay? So let's go to our DRC. Okay. Now, this board was actually created by, these boards were, when they were manufactured, they were actually done by Sunstone. Right here you see Sunstone. And Sunstone provided the developer of this board a DRU file. So they actually loaded the DRU file from Sunstone. So they went to the Sunstone website, they downloaded the DRU file, and you just click here on load and load that. And you want to do that before you actually start laying out the circuit board, okay? You don't want to do that afterwards. It's best to do it before you actually start laying out the board, and especially before you start doing any routing, okay? Before you do any routing. Okay, here, let's take a look at our layer stack up. Let's see what's going on here. Now, here we have a 4-layer stack up, okay? So we got a top layer, a bottom layer, and 2 internal layers, okay? So we got our core and pre-preg, okay? So the plus sign and the asterisk basically is just referring to the pre-preg. Now, as you build your layer stack up, it creates the setup, as you could see here. Now, we also have a little bit of different setup that we had in our initial example. You'll notice that I have a via that travels from the top layer to the inner layer 2, okay, which is the setup that you see here. That's the setup that you see here. That setup is defining that it's traveling from the top layer to the bottom layer. I also have buried vias. This is referred to as a blind via. I also have a buried vias, which is from the inner layer, layer 2 to layer 15. Remember, I stated earlier that you always work from the outer layers to the inner layers. So I have a blind via, a buried via, which is going from layer 2 to layer 15. We encourage you to stay away from blind and buried vias, just because it's quite a bit of a cost to actually get these made, okay? But we can handle it, but the cost of getting boards made using buried and blind vias gets pretty expensive. So I just want to let you know there. Now, how were these defined? I went over here where it says via pairs, and here you could actually do the association between the layers for the points of transition. So I go from layer 1, I could go to layer 15, for example, which I already have, and I say, okay, that's going to be one pair, as you could see. Now I have a via that travels from the top layer to layer 15, as you could see. It's pretty easy to set this up, okay? Clearances, you should always check these, verify before you actually do your manufacturing, distances, and so forth, okay? I'm not going to go, we already did that. Now that we've accomplished this, I'll just cancel out of this. You've taken a look at what's going on. Then I'll go back to design and run my rat's nest. That way I could take a look at my board. I'd like to see what exactly it's going to look like. It's a 4-layer board setup. Let's go to manufacturing. Let's go ahead and preview it. Preview this. You know, I have one of these here in the shop. I should have had it handy. That way you could see it actually made. I think Jorge bought these. We have here some in the shop. So this is what my top side is going to look like when you receive this in the mail. This is going to be what my bottom side looks like. See this in the mail. Again, you could go through the different statistics of the board. How many drills, pads, components, layer stack up, all the statistics necessary to actually get the board manufactured. Now I'm going to go back to the preview, because from here what I'm going to do is I'm going to actually go to the CAM processor. Okay, you'll notice that we have a button option here. Right here, it says CAM. Right there, it says CAM. I could go to the CAM processor. I could do it from here, or I actually can click right there as well. I could click right here to go to the CAM processor. Either way, I'm just going to do it from here, from the manufacturing preview. Click on the CAM processor. Give it a minute. Now, the nice thing of the CAM processor is that I'm able to make some manual modifications, okay? I could add layers. I could get rid of components. I'm not components. I could get rid of sections that I maybe don't need, even though that's not really necessary, usually not with the default one. So first of all, I want you to remember that this was a 4-layer board. Therefore, the CAM processor loaded a 4-layer template, as you can see right there. Automatically identified that it's a 4-layer board from the DRC. Therefore, it loaded a 4-layer template. Okay. the outputs are actually divided into like 1, 2, 3, kind of 3 sections. We have our Gerber files, which is everything that has going to do with your copper and your silt screen and your solder mask. Okay, and I'll show that to you in a minute because I want to do this process first and then I want to go back to the editor. So this is your Gerber file, which is this is where you set up the type of Gerber file we have. By default, we use Gerber 274X. You have a couple of options, X2 and X2 and 274X with comments. If you just highlight right here, it will actually, let me go here. Did it earlier today. There it is. So if you just hover your mouse for a second there, you'll get a full explanation of exactly what's the difference between X2, 274X, and 274X with comments. And it actually puts, you kind of see the code of the difference between each one of them on the output, okay? So if you want to hover over there as well. You also set up what the prefix is going to go, where it's going to, the path it's going to take, as well as what's the name of the file going to be as well. You could set up if it's going to be a zip file. In this case, I don't want to zip them up, but you could select the option and you could export to a project directory, which is, I'm not going to use this option because I'm actually using Fusion 360. So I want to go to a local one. So I'm not going to use this option right here. Of course, we have the copper top side. That's the Gerber side. And you actually have a preview. This is kind of neat on the scan processor because I actually could preview it. And you notice that it's using the top layer, the pads, and the vias. Okay, as you can see, it's using those 3 layers. Remember, I did that earlier today. So this preview lets you take a look at what the layer selection is. So I have Route 2, which is layer 2 combined with pads and vias. You notice that it always combines pads and vias because those are copper. Okay, layer 15, which is that layer 15, which is primarily kind of a power layer, as you can see here. It's a power plane. It's all filled up with copper. And it includes the pads and vias because those are actually going to be copper as well. Then we have our bottom copper. Our profile is going to be the board outline, okay, and whatever holes they need to be on the board outline. These are non-plated holes primarily. We have a solder mask. The solder mask is what creates that the color of the board. It could either be blue or usually it's green. And that's going to protect the entire circuit board. It protects all the traces, and it only leaves openings for those areas that are going to be soldered to. So it will only expose copper for those. Everything else will be protected. And that's the T-stop layer, as you can see here, layer 29, and so forth. Okay. Now the second section is our drills. Okay. Our drills, and I'm just going to cancel this just for a minute because you'll notice that it creates a drill file per drill profile. Therefore, you remember that I had blind vias going from layer 1 to layer 2. Therefore, it actually needs to create a file for those vias only. And you can see here, it's going from layer 1 to layer 2 because it read it from my DRC. So it's going to create an output called drill_1 to 2. Referring to the fact that I'm going vias that are going from the layer top to the inner layer 2. The next one it's going to create is from layer 1 to layer 16, which is the majority of my vias, okay? Going from the top layer to the bottom layer. Then we have our next one, which is going from layer 2, which is, remember I was telling you blind vias? The ones that are going between the internal layers, between layer 2 and layer 15. Those are going to be 3 separate files. That's not going to be one file, okay? It's going to be 3 separate files. Now, I have encountered that some users sometimes when they're using this format, they run into some kind of the board house may not interpret what's going on. Therefore, what I've told them to do is, and this only happened once, okay? So it's not something that happens often. Right here where we have the plus sign, right here and down on the bottom, it says I could add an output. I could click here where it says add an output, and I could select an Exelon output. Okay, we have auto drill here, which is the driver that's being used. I could tell it I want an Exelon output. I'll click here. On the Exelon, by default, it's going to go from layer 1 to layer 16. Okay, so it's going from the top layer to the bottom layer. Those are all these vias. I'm going to click on it one more time, and I'm going to go ahead and make a modification. My next one, I want to go from layer 1, but instead of going from layer 1 to layer 16, I want to go from layer 1 to layer 2. You'll notice that I only have a few vias like that. See, I only have a handful of them, vias. These are the vias that are traveling from my top layer to my inner layer. Okay. If the board house has a hard time using our auto drill, you could go ahead and set this up manually, okay? So let me change the name of this one because it's layer 2 here. And I would actually go ahead and delete this one here. I would actually, and not because I will be using this one here, okay? Oops, yeah, okay. Oh, the other thing I forgot to tell you on the Gerber, we're actually using 3 integers and 4 decimal points as well, okay? Okay, let's go back here. Now, on the Gerber file, there's one more modification I wanted to do. Let's say, for example, you've imported a logo to one of the layers in Eagle. And let me just exit here. As you know, Eagle has many layers, and it can handle up to 256 layers. But we have layers which are not by default used on your CAM processor output. They're not part of the default process. But there's a chance that you may want to use them as part of the process because there's some information there that you actually want it to be printed on the circuit board, like additional silk screen. Here, I'm going to go ahead and disable all these layers and turn on the layer called document layer. I think I put it on here. No, I put it on the TDoc layer here. There's some additional information that is here that I actually wanted to show up on the board. It's not very common, but let's say, for example, I was to import a logo. I would most probably import this on the TDoc layer. You don't want to import logos on the regular silk screen layers because you want to manipulate those separate from logos. So most probably you would use a TDoc layer. If it's a logo, it's going to be on the top side of the board, or if it's a logo going to be on the bottom side, you would use the BDoc layer. So that documentation should be on the doc layers if you want to. But as you already know, you do have the ability of actually creating additional layers if you want to, right here where it says add new layer. And here you'll notice that apparently a logo was imported. That's why you have this BMP files here, because a logo most probably was already imported. But you could go ahead and create new layers. Now layers 1 to 100 are layers that only are used by Eagle, so you cannot configure those. But anything between layer 101 to layer 256, you could create those layers. So I want to go ahead and configure my CAM processor. That way I could create an output that's going to appear on my silk screen, most probably, that is going to include this information that you see here, okay? So it's going to look something like this on my TDoc layer, okay? And if I want to create this as maybe as a separate silk screen that I want the board house to include, let's go to the CAM processor and learn how that would be done. So I'll click here on manufacturing. I'll go back to the CAM processor. I'll go to the Gerber file, to the section which is doing my silk screen for the component side. So I'll go here where it says silk screen component side. As you could see, we have that there. But if I wanted to include additional information here, like such as a logo, I would click here and right there. Let me just go a little slower. I think I went a little too fast right here. This is where you actually could add more layers. That icon that you see right there. Click there, and I'll go ahead and select the TDoc layer. Keep on going, the TDoc layer. And click OK. So you'll notice that we have some additional information that is going to be showing up on my silk screen. Now, you could do that as part of the silk screen layer, or you could just go ahead and add a section to my Gerber output. So I could just click on here and click on add. I'll select another Gerber output. I'll click here and I'll select that layer. Okay. So that way you could manually configure and add layers if necessary, if you need your manufacturing files to have additional information. So I just wanted to bring that up, okay? Now, we have our drill files that we already had done already. As you know, we have 3 sets. Now for assembly, these are text outputs that are actually going to be added to our output as well. We have, first of all, our bill of material. I just forget to use the arrows. We have our bill of material and we have our pick and place. The bill of material is gonna be by values, okay? The bill of material is gonna give me a number of components that I have. It will list the components as well, but it will let me know I have so many resistors of this size, 0805, for example. I have many of these, and it gives you the X and Y coordinates as well. The pick and place does the same thing, but the pick and place will list each component per line with its X and Y coordinates. That way, if you're going to have these boards populated, manufactured and populated by the board house or by the manufacturing house, which they will use a pick and place machine, this ASCII file can be easily configured for that as well. Okay? Okay. Now that we've already explained, let's go ahead and output this file. I'm not going to zip it up. So let's see what's the next step. I'll click on Process Job. As you could see, it's going to go to, as you could see, it's going to the Fusion 360 local under Documents. It's to my local drive, Fusion Electronics Cam. I'm going to go ahead and just create a new folder here. I'll call it BBW. I want to put it there, and I'll click Open. Okay, I'll click on Open Folder. That way we could now just discover where the files are located and what files were actually created. Okay, puts my name because I am the. Okay, I'll go ahead and expand this. It creates a that's the entire the Fusion 360 folder, and this is the hub I'm using, which is mine, and the folder. And here are the CAM outputs. And you notice that it sets it up in 3. Just like it did in the CAM processor. You see it has 3 of them. Okay. So, okay. So we'll start with assembly. We have this is kind of like a summary, all the information on the board. These are all text files, very simple text files. Here we have the pick and place. That's a PNP file. It lists every component and the X and Y coordinates and its rotation. That's what you see here. Here we have, this is for the top layer. This is for the top side of the board. And this is for the bottom. I'm sorry, the other way around. This is the back side of the board. And this is the front side of the board. Okay. Remember, this board has approximately like 200 parts. So it actually has components on both sides. Here's our bill of material. The bill of material actually is listing the components per quantity. So you'll get a list of, say, I have 4 10Ks resistors using 0804, 0402s right here, as you can see right here. It's just one simple example. And it will list every component I have, okay? The drill files, as you can see, I have 3 of them. I have 3 drill files. So these are the drills from 1 to 2, the drills that are going from the top layer to layer 16, and all the drill files that are in my internal blind, my blind vias, which are going between layer, I'm sorry, not my blind, my buried vias, which are going from layer 2 to layer 15. Okay. Now we have all of the Gerber files. Remember, we did it from, it was a 4-layer board. Therefore, we have our layer 1, which is top pads and vias, layers 2, layers 3, and layer 4. Okay, those are all my copper Gerber files. Okay, there's that one step that I did called Other. Remember that I selected the TDoc layer, so we have that one there. The board outline, which is the profile file. We have our silk screen for the top, my silk screen for the bottom. These are these 2. My solder mask, which is, it's a negative layer. as you may already know, the solder mask layer is a negative layer. Therefore, it's only providing the board house the information necessary for where the copper is going to be exposed. Everything else is going to be masked. It's going to be that way. It protects the traces. So we have our solder mask for top and bottom, and then we have our solder paste for top and bottom. Solder paste is commonly used when you're going to generate your stencils. Okay. Now, there's a couple of ways of maybe you could preview your Gerber files. There's a few programs out there. For Mac, there's not many programs. Let me see. I do have one that I've used in the past for Mac. Let me see if I could find it really easy here. Oh, it's right there. You saw it. Let me see if I could open this up really quick. It's called Cuprum, and you could find it in your you'll be able to find it in your I'm having some trouble loading it. I don't know why it doesn't want to load. Go ahead and quit it and see if that fixes it. I practiced much earlier with it. It was working just fine. Okay, there it goes. Okay, very well. File new. So really easy to take a look at your Gerber files using Cuprum. You'll find this in your, if you're using Mac, you'll find it in the App Store. So I could click here, it says yes plus to import the Gerber files, and I could just find the files. That's under Documents. Let me go to my Fusion 360 folder, which is right here. I have a shortcut for it. My electronics cam files, and I'll select my Gerber files really right here. And there it is. Okay, so, and then you could just drag and drop the order of this. It's showing you in the order. So let's say, for example, I take, and it's kind of nice because it does understand the file format that Eagle uses, which is a standard 274X format. There's nothing really extraordinary of it, but you could take a look at your Gerber files and make sure that this is what you're actually going to get in the mail when you actually get your boards actually made, okay? So that's it. Here's our silk screen. We could just drag this over to the top. That way it shows up on the top of my copper, and this is my silk screen bottom, so I could put this here. That way it kind of shows up the way it would show up when you're working. And then there's another one, I forget the name, but if you just Google Gerber viewers, there's some that are online, depending of how delicate your design is. If it belongs to a company or something like that, I would not use an online service. I would definitely download one. But there's several out there that you could download, which are free. You just got to register for them. Well, this covers all the material that I wanted to cover today. The 2 ways of how to generate your manufacturing files, the one-click solution, as well as using the CAM processor and configuring the CAM processor for any type of custom modifications that needed to be done. I greatly appreciated everybody that joined us today. If you have any questions, please join us on the Fusion 360 forum, and we'll take care of all your questions there. It's been a pleasure. This was a short tutorial that I just wanted to create, just because we had quite a big need for many Fusion users that wanted to take a look at actually creating customizations when they're creating their manufacturing files. Thank you, everybody, for joining us, and have a great day. Jorge, and thank you for manning the chat. I greatly appreciate it. Everybody, have a great day.